Our final speaker for this afternoon is Scott Kehler, President and Chief Scientist at WeatherLogics, Inc. He's here to share with us what's the forecast. Like I said, Scott is President and Chief Scientist at WeatherLogics. Prior to co-founding WeatherLogics, he completed a bachelor's and master's degree in meteorology at the University of Manitoba. While at the U of M, he researched the influence of the Manitoba lakes on the weather and how severe thunderstorms form at night. This research has been published in multiple peer-reviewed journals. In his current role as Chief Scientist at WeatherLogics, Scott conducts weather research and develops tools to help clients plan for all weather conditions. Scott still enjoys weather forecasting day-to-day weather and is often involved in preparing forecasts for high-impact events. So with that, I will welcome Scott here to the stage.
Good afternoon, everyone. Thanks for joining me for my favorite topic, of course, which is the weather. So here's a quick overview of what I'll be talking about today. We'll start with looking at what different factors affect weather on the prairies, moving into what happened last year in terms of the weather conditions, and then looking at current soil moisture and snow cover, and then, of course, ending with the always accurate outlook for 2020. So I think most of this was already stated, but my background is mainly in research, particularly around the Manitoba lakes and thunderstorm activity. And as I'll talk about a bit later, we're predicting the thunderstorm season in addition to temperature and precipitation trends. So to start off with, what I like to talk about is what are some of the factors that affect weather on the prairies. You know, of course, that we have very volatile weather. It ranges from very dry to very wet. We get severe storms, sometimes even snow during the growing season. But here are some ways that we can really attribute that weather to certain factors. When we talk about seasonal weather conditions, the main thing that meteorologists refer to is something called synoptic scale weather, which is the weather on very large scales. So even though the prairies is a large region to begin with, it's even larger factors that affect our weather. The jet stream is one of the main controls that determines if we're going to be in a wetter pattern, drier, warmer, or colder. And the jet stream configurations are based on very global trends because the jet stream flows all the way around the globe in a fairly erratic and sometimes chaotic fashion. And so the weather in different parts of the world can deflect the jet stream in one way, which then propagates downstream and can affect our weather across the prairies. The jet stream is often divided into a bunch of different segments, which we call ridges or troughs. A ridge is something you may have heard of before when somebody's giving the weather forecast. It's when the jet stream is deflected off to the north, allowing a lot of warm air from the south to move up. The opposite is a trough when the jet stream is deflected to the south, and that allows cooler air from the north to flood farther south. And those troughs are often associated with the more active weather like big rain or snowstorms or sometimes even big thunderstorm events. Whereas on the other hand, the ridges tend to be calmer weather that is drier and warmer. If neither of those two things is in place, it's what we call a zonal flow, which is where you have the jet stream basically going from west to east. And as I talk about what happened last year and then also moving into what's going to happen this upcoming year, you'll see how those different configurations of the jet stream show up in our different weather forecasts and weather patterns. So here's just a visualization of what that looks like. And you can see that there, in this case, it's a ridge over Manitoba. The jet stream deflected well up to the north. So that would be for us probably a warmer and drier pattern. along the west coast, you can see a trough here, and so that would probably be a cool wet pattern for them. And let's say a place like Alberta, which is kind of caught between the two, because the jet stream is actively moving up into that area, it's carrying weather systems with it. So when the jet stream is just kind of encroaching on an area like that, it often becomes quite active weather-wise. And that's a lot of what we saw last fall with all of those weather systems proceeding through in September and into October, giving us all of those really big rain events, and also in October, the big snow event. So when we connect what's happening with the jet stream to what's happening at the ground, we can use a diagram like this to show the connection between the two. The jet stream aloft also has a lot to do with whether or not you're sensing a high pressure or low pressure system at the ground. And that's usually what you'll see on a newscast weather map. You'll see those highs and lows moving across the continent. And if you have a barometer at your house, when the barometer is rising, usually you would say that's high pressure moving in, or if it's falling, low pressure. And so you can see with this graphic here, if the barometer is falling, that's a little low pressure zone, because what's happening is the air is rising due to something aloft going on. Usually it means the jet stream is overhead, causing a lot of rising air, which forms into clouds and precipitation. The other way around, if you have a ridge, you've got sinking air, and all that air is moving toward the ground, raising the pressure, and giving you high pressure. And with high pressure, when you have sinking air, it tends to dry out the air and also warm it up, and that's why under those conditions, it's usually clear skies and warmer temperatures. So actually, agriculture itself has some effects on weather. You might have heard this referred to as something like a feedback before, where something happens, it reinforces a pattern and causes it to continue. Well, with agriculture, one of the interesting things is that the crops that we plant behave a lot differently in terms of their release of moisture than the prairie grasses that preceded them. Here we have a little picture of a plant, and you can see all the inputs that affect that plant, whether it's evaporation and precipitation, which was talked about a bit in the previous presentation, or the third factor, which I'm mostly going to focus on, which is the transpiration part, which is where the plant is releasing moisture back to the atmosphere through its leaves. And that's the important part in terms of weather, because if you have crops that are able to release moisture back into the atmosphere, that moisture is then available to clouds to form more rainfall and produce further rainfall events. And usually in meteorology, what we'll do is combine the evaporation and the transpiration into one term called evapotranspiration, basically referring to all of the moisture released both by evaporation of water out of the ground and soil, and also what the plant itself is releasing. And when the plant begins to release moisture through transpiration or the ground through evaporation, it's feeding into this whole water cycle, which is the global system that transports water both through the atmosphere, down into lakes, rivers, and oceans, and also runoff over the landscape. So you can see how everything is connected. You get that evapotranspiration coming off of plants, not just crops, but any plant. That's feeding back up into the atmosphere. And the atmosphere then has moisture, which can produce as precipitation back as rain or snow. That rain or snow then runs off, goes back into the oceans or back onto the land, where it's then available to go back into the air again and start everything over again. So that's kind of the cycle that all of this plays into. And the type of crop is really an important factor in determining how much transpiration occurs. If you have something like wheat, it doesn't require as much water, and it also releases less water than something like corn. Corn is known for being a very prolific transpirer, and if you live anywhere from southern Manitoba or even southeastern Saskatchewan all the way down into the north-central U.S., you'll know there's a lot of corn growing, especially basically from the Dakotas and Minnesota south into Iowa and Nebraska. There's corn everywhere, and corn releases a tremendous amount of moisture. You'll see that 1 acre of corn can transpire approximately 400,000 gallons of water per growing season. Now, it depends on how much water is available to the plant. If it's a drought year, it might be less, or a really wet year, maybe more, but that's sort of on average. Wheat, even though it's a drier type of a crop, it still releases quite a bit of moisture too, 5 millimeters of water vapor per day. And if you were to factor that into how much that could raise something like relative humidity or another measurement of moisture called the dew point, it can have a noticeable impact. And the reason why I bring that up is because, as I'll note in a little bit, the amount of moisture and therefore the humidity that you've got in the atmosphere is a big driver of thunderstorm activity. Thunderstorms are fueled by warm and moist conditions, and because of that, the more humidity you've got in the atmosphere, the stronger your thunderstorms can become. And when you've got all that transpiration occurring, it also can have impacts on other aspects of weather, just the daily temperature, for example. It's not going to raise the temperature, but because it raises the humidity, it can feel a lot hotter. And that's why the Humidex record for all of Canada was set in Carman in 2007 in the middle of July, when you had tons of transpiration occurring from growing crops all over southern Manitoba. But remember, we oftentimes, during heat waves in the summer, have a strong flow out of the south. So all that moisture from the corn crops in Nebraska and Iowa, Minnesota, all that's headed our way too. And it kind of ends up here. And on July 25th, 2007, the conditions were just right that all the humidity kind of collected in southern Manitoba and set that Humidex record. On that day, the temperature in Carman was only 34, which is a temperature we see at least once pretty much every summer, if not more. But the humidity was extremely high that day. I don't recall the relative humidity, but the dew point, which is what meteorologists use to measure moisture, was 30 degrees. So there was only a 4-degree difference between the air temperature and the dew point. If those air temperature and dew points are the same, you get 100% relative humidity. So you can see, even though it was so hot out, the relative humidity was extremely high that day. And this is kind of the impact that has on precipitation, because like I mentioned, the amount of humidity in the atmosphere can help to drive more thunderstorms. And because of that, we've seen a shift in the trends in thunderstorm activity. Before we had crops growing on the prairies, my pointer's not working, but anyway, the one on the left is before we had crops in place, so the grassland conditions. And under grassland conditions, your grasses started to grow earlier and kept growing later in the year. And so you had a longer period where transpiration was occurring, but because grasses don't release as much moisture as some crops, especially crops like corn, the peak in the season was lower than it is now. So you can see on the right panel, the thunderstorm season starts off a little bit more slowly, but then by July it really peaks, it really maximizes, corresponding with that maximum in transpiration from all those growing crops. And that's also why in drought years it can oftentimes reinforce itself to some extent, because if you have a drought, you don't have as much moisture available to transpire, therefore the crops are returning less moisture to the atmosphere, and as a result you can get less thunderstorm activity. Now even in drought years you can definitely still get plenty of strong storms, but the likelihood of getting a large number is less if you have lower humidity levels from less moisture coming out of the crops. So that's just my brief overview of how weather on the prairies is affected by a few different factors. Now we'll go into what happened last year, which was a year of very volatile weather, starting out very dry and ending up very wet. So before I get into the precipitation trends, here was the temperature trend. So you can see there on that table, the difference from normal in cities across southern Manitoba was not really that significant. Pretty much everywhere was just slightly below normal, anywhere from 0.2 to 0.5 degrees below normal, except if you happen to live in Portage la Prairie, you were almost exactly normal, just 0.1 of a degree above. The wetness was really the story, though. You can see, I don't need to tell you that September and October ended off basically in a flood when the start of the year was a drought. Now, there were a few patches of Manitoba that were spared from that deluge in the fall. One was kind of the Parklands area of western Manitoba. For the most part, that area fared a bit better in the fall, but pretty well everywhere else got just absolutely soaked. And you can see here, Winnipeg, even though the year started out, the first half of last year was the driest on record, it still ended up above normal for precipitation. Brandon, 135% of normal by the time we got to the end of October. And like I mentioned, that Parklands area around Dauphin, it still got some moisture in the fall, but it didn't actually end up above normal. They didn't get hit quite as hard. But that previous slide was for the entire growing season, at least what is usually used as the growing season for climate data. So that data was from April through the end of October. But if you were growing crops that really needed the moisture a lot earlier in the year, let's say spring into early summer, it probably kind of seemed more like a really dry year to you. Because if we do the same stats, but from April to July, you see everywhere in southern Manitoba is below normal in terms of precipitation. And it's compounded by the fact that the previous 2 years were also very dry. And you can see in the anomaly, not just if you look in the anomaly column, you see how much moisture we lack compared to normal. Almost all those locations are in the 75 to 100 millimeter range, which is 3 to 4 inches below normal up to July. And that's on top of all of the moisture deficits we had in previous years. So what I did is I came up with this interesting little chart which charts the precipitation that Brandon received from the start of 2017 until the end of 2019. That's the blue line that you see. The black line is what's normal for that time period. So you can see the blue line is consistently below the black line from the start of 2017 all the way to the end of 2019, even including all of the precipitation from the fall of 2019. At the very start of the chart, you'll see that there was a brief period at the start of 2017 where the precipitation was basically trending right about normal. But then from kind of spring to early summer of 2017 onward, consistently below normal. And the gap between normal and what we actually got kept getting larger and larger. And the maximum gap was in August of 2019 when Brandon had received over 300 millimeters less precipitation than it normally would over that time period. That's about 12 inches of precipitation. And then you can see right as kind of August ended and we moved into September, suddenly our totals go basically straight up, and that's all of that rain and snow that we got in September and into October. So you can see a massive correction there. So by the time we got to the end of 2019, the deficit between normal and actual had narrowed to just over 100 millimeters, so only about 4.5 inches below normal. That goes to show how wet the fall was, that we could actually make up 8 inches of moisture deficit in just a couple of months. And as you see, I plotted the amount of precipitation deficit every August 22nd, starting from 2019, going back every year. So you can see every year for the past 3 years, we had been in deficit about 4 inches per year, 100 millimeters per year. Luckily, that's narrowed now, but we still are going to rely on more precipitation in the future to bring us right back to normal. We did have all that moisture in the fall, which will be a huge benefit come spring, although it wasn't such great timing happening kind of during the harvest point of last year. And here are just some more stats illustrating how wet it was last September. All of the locations on my map there had their wettest September on record, and actually Carberry had its wettest month of all time in September. I think 179 millimeters is what it says there, or about 7 inches of precipitation just in September in Carberry. Wettest month of all time, including every other month of the year, including the middle of summer when sometimes there's big storms. Places like Winnipeg, even though it's not on the chart here, second wettest September, and it was only missed being the wettest by a few millimeters. So even if a place wasn't a record last September, it was still probably top 5 wettest fairly easily. So here's how we ended up by the end of 2019. Even though the year started off really dry, by the end of the year, the totals of precipitation compared to normal ended up being above normal across most of the eastern prairies. Like I mentioned, the Parklands area, kind of Dauphin up towards Swan River, did not benefit so much from all that rain, but pretty much everywhere in the southeast corner, from a large part of Saskatchewan into most of southern Manitoba, ended up above normal. And then on the right chart, you see what the actual totals of precipitation were. So across the whole prairie, some of the highest totals for 2019 were in the far southeast corners, sort of centered around a place like Steinbach and Sprague. And that's getting into some forests where there isn't so much agriculture, but that's where the highest totals were. So I know we probably have a few audience members from outside of Manitoba, so I threw in some stats for other parts of the prairies, but you'll notice here for temperatures at least, there's really not much difference. Almost everywhere was just slightly below normal last year. But one thing I always like to point out to people is that while someone in, let's say, Calgary can boast at this time of year that, well, they're getting a Chinook, so it's +5 in the middle of January, in summer they can't boast quite so much because you can see their normal temperatures for summer are a fair bit lower than ours. Calgary, average summer temperature only this is April through October, so average during that period only 10.7, Edmonton only 9.7, Winnipeg 12.2 is the average during that time, so a fair bit warmer, over 2 degrees warmer. Brandon and Dauphin 11.3 during that period. So while the western prairies along the mountains, they get some of those warm-ups midwinter, they can't boast about the heat so much in summer. So while a place like Calgary was colder than normal, they're actually significantly colder than we were. You can see that their mean temperature was 10.7, which was only 0.2 below normal for them. But even though they were 0.2 below normal, and Winnipeg was just 0.3 below normal, very similar, our mean temperature was 12.4. So it goes to show that normal is sometimes a tricky concept because normal varies a fair bit across the prairies. Even though both us and Calgary were below normal, we were still quite a bit warmer. And then Saskatchewan, right between the two, is kind of an average. So you can see Regina was colder than normal as well, but they were still warmer than Calgary and slightly colder than most of southern Manitoba. Precipitation was a much more mixed bag. Of course, Manitoba, for the most part, ended up above normal. A fair amount of Saskatchewan did as well, mostly the southeastern part of the province, so kind of Regina and Moose Jaw and eastward. The Saskatoon areas and more toward the western parts of Saskatchewan were on the drier side. And then Alberta as well was a bit variable. Edmonton was not far from normal. Calgary was above and Lethbridge quite a bit below. But again, note what normal is. A place like Lethbridge only gets 300 millimeters of precipitation per growing season, whereas in a normal growing season, Winnipeg will get over 400. So for Lethbridge to only get 214 last year, and that being below normal for them, imagine if Winnipeg only got 214. We expect a lot more precipitation, so for us to get that little amount would probably be a big record. So at the start of the talk, I mentioned kind of jet stream configurations and how they affect weather on the prairies. Well, here's a few different graphics showing what the jet stream looked like during different months of last year. You can see in May there was a big dip in the jet stream, those blue areas across the western U.S. and eastern prairies. Then by the time you get into July and August, there's some strange patterns kind of going on. In July, the jet stream is split into two parts. And in June, it's split into two parts. July, it's kind of looping down through the western part of Canada. August, there's a trough over us. As you can see, that big blue area indicates the jet stream. A measurement that we used was below normal at that time. And in September, there was a big ridge across the eastern part of North America and a trough in the west. And so for some reason, well, I shouldn't say for some reason, but I haven't drawn the jet stream flowing from west to east in this case. But you can kind of imagine that the jet stream is coming in from the west coast here and flowing between these two different systems. And because it's flowing in between the two up into Manitoba, it's kind of directing a lot of weather through our area. And that's why there was so much active weather in September, because the jet stream was frequently carrying weather systems through Manitoba and other parts of the prairies. In October, we have a massive trough kind of centered over the southern prairies. And of course, I don't need to remind you what happened then, that record-breaking snowfall. And how quickly things changed because of all that fall moisture. We started out last year in a drought scenario across most of the prairies. You can see abnormal to severe dryness over large areas. And then by the time we get to the end of fall, into transitioning into winter in November, almost all that's gone because of how much fell in September and October. So then moving into current conditions, I like to quickly go over what's happening right now before I show the summer outlook, just so you have a sense of what things are shaping up to look like this spring. You can see here current snow cover. I've just shown the eastern prairies is almost non-existent over southern Saskatchewan, very little in the way of snow cover. And then it gradually picks up as you go through southern Manitoba. The highest snowfall or snow cover in southern Manitoba right now is kind of in the Red River Valley and southeastern corner. And places like Winnipeg, Morris, down even toward Morden, have benefited from a bunch of frequent snowfalls in January already, which have helped to boost those totals. And you can see I've shown snow totals from November 1st through January 19th, which is kind of the end of the last snowstorm. Winnipeg tops the list at 66 centimeters. Then you have Schonzenfeld, which is near Morden-Winkler, at just about 50, and Brandon around 40. And I like to point out here, you might be wondering why I picked those three stations. No, Winnipeg and Brandon might be obvious. Why did I pick Schonzenfeld? Well, there's actually virtually no weather stations anymore that measure snowfall officially. Winnipeg Airport doesn't even do it. This Winnipeg total I'm showing there is from a volunteer who does it just out of the goodness of his heart, essentially. Brandon Airport is one of the very few, if only one, in southern Manitoba that still measures snowfall, so I have that one. And the Schonzenfeld one is, again, a nice volunteer who happens to measure snowfall. So some of you probably have heard of the CocoRez network, which is, again, volunteers who measure snow and precipitation. I don't use their figures here. These are from the federal government, but CocoRez is kind of replacing the snow measurements we've lost that the federal government used to take care of. And in terms of normal, well, up to this point in the winter, from November 1st till now, about 57 centimeters is normal. So Winnipeg and Morden-Winkler are not too far from normal, but Brandon is a fair bit below normal up to this point. And another thing I like to show is the snow water equivalent or liquid equivalent, which is really the critical thing, especially when it comes to spring flooding and how much moisture you're going to have to work with come spring. So this number is basically saying, what would happen if we melted the snow? How much moisture would that give us? And you can see across Saskatchewan into western Manitoba, we're very, very much at the bottom of the chart. So that means less than 1 inch of moisture is currently sitting on the soil in the form of snow. As you move farther east, those numbers go up a little bit, but we're still relatively low. For those Red River Valley farmers, I'm sure you're concerned about spring flooding, and you can see it's a bit of a concern at this point because the Red River Valley in the U.S. has some of the highest snow water equivalents to this point. Fargo and Grand Forks are in the higher amounts on this map. They also, Grand Forks just came off of its wettest year on record in 2019 as well. So Red River flooding will be a concern depending on how much more snow we get through the rest of the winter, and then also how quickly the spring melt transpires. Lastly, soil moisture. You can see in the blues, higher than normal. This is from satellite taken in November, just before freeze up, it says late October. And you can see the highest amounts are in the southeastern prairies, getting drier through Saskatchewan, and then getting a little bit more moisture again as you move toward the more mountainous parts of Alberta and around Edmonton as well. So now the part you've all been waiting for, and the part that you could probably bet everything on, right? The 2020 outlook. So what I do is I prepare a summer outlook for June, July, August. Well, I guess around this time of year is when I prepare it, and then it goes for the next summer. But again, a lot of people, much to my dismay, are skeptical of me. So what I do at this point is I say, well, how did we do last year? So you can see that I'm not just going to give this forecast and run away and you'll never see me again. So here is what we did last year. You can see that the top map was temperature forecast. We were predicting, you can't read the text, but it says warmer than normal, but cooler than 2018. 2018 was a really hot year, so we were basically saying slightly above normal. For the most part in Manitoba, we ended up more normal as opposed to slightly above, so that was a bit off. However, the one that people really cared about last year was moisture, because they wanted to know, is the drought going to end? And we were basically saying for southern Manitoba, it was definitely going to be a wetter year. And it was, but this is the caveat I always like to point out. The forecast was correct, but it may not have helped you if it all came at the end of the year when it didn't matter. So even if the forecast is correct, as the precipitation one was last year, that doesn't always mean that it's going to work out in the way that you had hoped. So in developing these summer outlooks, we tend to look at a few different factors. One of them is local weather and what's going on right now. So what are the trends in soil moisture? What was snow cover looking like this winter, and how is that going to affect soil moisture come spring? Also look at how that might relate to things like the transpiration in upcoming summer, because that could fuel more thunderstorms, which in turn, of course, fuel more precipitation. Global weather is probably the biggest thing that we would look at. So what's going on around the world? Are our oceans warm? Are they cold? You've often heard terms probably like El Nino or La Nina, which is the Pacific Ocean warmer or colder than normal? Right now it happens to be what's called neutral, which means it's neither warmer or colder than normal. So in those scenarios, it doesn't tell us as much as it would otherwise. Lastly, sometimes we can look at things like sunspots. So is the sun particularly active at a certain point in time? Although I found in recent years the sun has actually been quite inactive. And so for that reason, I haven't really spent much time looking at that, just because it hasn't been very helpful. Another thing that I look at as I develop these forecasts, I try to figure out what previous years might be similar to the upcoming year. And so here I've listed three of them, 91, 04, and 07. And if you combine the trends in all of those years together, here is kind of what you come up with. So on the left-hand side, you'll see temperatures. The western prairies, it's showing kind of warmer, and the eastern prairies kind of cooler. And then as far as precipitation goes, there's far less of a signal. You do see a few patches of color here and there, but when there's so little in the way of an anomaly showing up, there's nothing strong one way or the other. I don't tend to read too much into it. So I'm just saying precipitation-wise, if you combine those years together, it's not telling us a whole lot. Now, I know some of you are probably remembering some of those years and thinking, oh, that was a really wet year for me or a really dry year. Well, I'm sure, as you know, on a local level, one year can be really dry for one person, and your neighbor, it maybe isn't so much. So these are really overall patterns as opposed to what happened on every small location, which there's still variability within that. Now, just before I show our summer outlook for this year, in terms of temperatures, I just like to remind people again what's normal. So I talked a little bit about this earlier in terms of how a place like Winnipeg is normally warmer than a place like Calgary, and this map just illustrates that. So you'll see southern Manitoba is essentially the warmest part of the prairies in summer. There's also a little patch around Medicine Hat that's also similarly warm. But as a rule of thumb, as you move east to west, it tends to get colder on average during the summer season. So here's the outlook for 2020. As you can see, the northern part of the prairies looking colder, although that's probably not what interests most of you. So for the southern areas, we're looking at probably a smaller warm patch just across the far south of Alberta and Saskatchewan, maybe edging just into southwestern Manitoba. But by and large, we're expecting, again, fairly normal conditions across the prairies temperature-wise. So not all that dissimilar to what we had last year for temperatures, which were also fairly close to normal, although a bit below overall. Then going on to precipitation. Again, as I mentioned earlier, the eastern prairies tend to be the wettest area. So you can see as you go, again, east to west, we tend to dry out. We're especially dry in southwestern Saskatchewan and southeastern Alberta on average. That area is almost desert-like in terms of its precipitation patterns. There's a bit of an anomaly of being drier in that area on average. But then as you move east into Manitoba, you get the wettest areas. The wettest corner of the prairies is around Sprague, so the southeast corner of Manitoba. And then as you move into eastern Canada, you get significantly higher precipitation totals as they get far more intense systems moving up the east coast. So precipitation-wise, again, we're looking at above normal precipitation this summer. But the good news is that we're expecting it will be a bit more spread out this time, not all coming in one or a month and a half at the end of the year. So we do anticipate that through the summer, probably more even precipitation. A lot of people are probably hoping that it doesn't all come right at once in the spring because things are still wet from last fall. There's no indication that it's all going to come at once in the spring, but as I am going to point out, there are some uncertainties with this forecast. So in general, I guess the story is above normal precipitation, but more spread out than last year. And then lastly, one thing I always enjoy putting together is the thunderstorm outlook for the next year. And before I reveal that part, here's what kind of is normal in terms of thunderstorm activity. So the map you're seeing there is showing kind of normal lightning activity, which we use as a way of kind of telling how many thunderstorms might have happened. There's two hot spots, so to speak. One is the foothills of Alberta. And if there's anybody here from Alberta, you'll know that the foothills of Alberta get plenty of storms in summer, and unfortunately plenty of hailstorms, as that's Hailstorm Alley of Canada right there. And then the other kind of hot spot normally is southern Manitoba. And like the precipitation trends, typically if you go a little farther east, the Red River Valley, southeastern Manitoba are a little more active than the western part. And those red patches equate to about 25 to 35 storm days a year. So storm-wise, this actually isn't a big surprise that we're predicting more storms than normal across southeastern Saskatchewan and southern Manitoba, because if you're expecting more precipitation than normal, you probably would also expect more storms, because thunderstorms produce a lot of our heavy rainfall events in the summer. So in the southeastern corner of the prairies, probably more storms than normal, certainly expecting more than last year. And then in the western prairies, kind of centered around Edmonton, a little bit less than last year. So in summary, I would say one of the big takeaways that I want you to bear in mind, though, is of the forecasts that I've done, and I do these every year, this is one of the ones I have the lowest confidence in, just because we don't have a lot of strong signals, and the signals we do have are very conflicting. Like I mentioned, there's no El Nino or La Nina this year, so the oceans aren't really telling us a whole lot. I've looked at all of the long-range forecasts from every agency. None of them say anything. And we've had very unusual weather the last few years, so I don't really necessarily believe we're going to see a continuation of what's been happening in the past recent history. So overall, I would say the highest confidence is in more thunderstorm activity, but temperature and precipitation overall, there's definitely more uncertainty than normal, and you know that these forecasts are very uncertain to begin with. So that's the main thing I would tell people to bear in mind with this one. And lastly, so I've gone through kind of our long-range outlook, but I thought I'd just mention how we, WeatherLogics, use our forecasting skills to help producers kind of more on a short-term and day-to-day basis. So we do subscriptions which give people the next 5 days of weather forecasts for their area. That includes things like general weather discussions, 5-day forecasts, hourly graphs. We also do include longer-range outlooks in that. So that's a service that we provide to producers because the long-range forecast, of course, is quite uncertain. But then when we get into the shorter range, which is what we provide producers on a day-to-day basis throughout summer, we're able to be a lot more confident, and these forecasts tend to be quite accurate and quite helpful for planning purposes. So our meteorologists use software like the one you see on the screen to adjust the forecast for every farmer to ensure that their forecast in the short range is as accurate as possible. When I say short range, usually we're focusing on the next 5 days, but we also do a longer range portion, which is up to 1 to 3 weeks, which gives you a sense of what's upcoming. And because it's only 1 to 3 weeks into the future, again, it's more accurate than the 6-month forecast because there's a lot more indicators at that point. So that's just kind of what it looks like. There's a lot more to it than that, but that's just a few samples of kind of what you would receive every day with your forecast. And this year, for those who've done this, received this information in the past, there's going to be an app which also aggregates all the information. So you'll get the same information that I showed on that other slide, just delivered through an app. And also you can see current weather conditions, current radar. That way you're not just receiving the information once a day. You can actually check for updates throughout the day. So that's kind of what that service looks like, and feel free to talk to me later if you'd like to know anything else about it. So that's the end of my presentation for today, and hopefully I've left time for a couple of questions if you have them. Thank you.
So, regarding the jet stream, you had the patterns here for the last little bit. Have those patterns changed over a long period of time, or what's going on with the jet stream? Why is it behaving as it is?
Well, the jet stream has always kind of behaved erratically like that, just because in order to get active weather, you need to have those big swings in the jet stream to promote kind of clashes of air masses which develop into weather systems. So the jet stream has always behaved really oddly like that, but what people are finding is those odd behaviors are tending to become more common now. And there's been some research which I haven't done personally, but which I've read, which suggests the fact that we have a warmer Arctic and not as much of a change in temperature to the south, weakening the temperature difference between the far north and the south. And because the jet stream is a divider of warm and cold air, if you make a change in that temperature difference, you can potentially get a more erratic jet stream develop between the two. So there is some research to that effect, not my own, but if you search for information on that, you'll see a lot of people discussing how that trend may be affecting the jet stream. Yep.
Aren't those ridges and troughs moving slower now than they did a few years ago, and that's why we're getting too wet for 2 weeks and too dry the next 2 weeks?
Yeah, if you do have a pattern where those ridges and troughs get kind of stuck in one spot for a prolonged period of time, then you get those really unusual weather patterns, like, for example, the extremely wet fall. Meteorologists refer to that as blocking. In other words, the jet stream is blocked from moving along in its normal fashion. So in the past couple of years when it was really dry, you wouldn't have noticed it so much because we were trapped more under the ridge part, so we were trapped under the really warm, dry weather, and other parts of North America, like I think it was in 2017 or 18, can't remember, but Ontario and Quebec had all those floods, so they were stuck under the wet part, we were stuck under the dry part, but last fall the roles kind of reversed.
Have you heard anything about the grand solar windows?
Yeah, actually, I kind of mentioned that when I was talking about the astronomical factors affecting weather. So right now, the sunspot activity is at a really low point, and it has been for a few years. So that's when they say grand solar minimum, they're talking about a prolonged period with very minimal solar activity. Normally, the sun goes in very distinct cycles where it's low for a period of time, then it goes back up and back down. But right now, we're in a particularly low period, and when it lasts and it's prolonged, they give it that special name.
Has there been any measurement of the intensity of the sunlight? Because myself, it's just an observation. Like when I was a kid, we had really bright, strong sun, at sunset or sunrise. Whereas now you've got really, really orange, just a lot of that sunlight. Any research about that?
I haven't seen any research specifically talking about the changes in the amount of sunlight, entering the top of the atmosphere. But in recent years, one thing we have seen, which sometimes isn't obvious, is that we get a lot of forest fire smoke drifting in, and it can cause those hazy orange skies. Even if that smoke isn't at ground level, it can be up high in the atmosphere where you can't smell it or really even tell it's there, but it will cause that kind of effect to happen, and it will weaken the sunlight getting received at the ground. Well, April technically wasn't part of the outlook that I gave, but as far as what I'm seeing right now, I'm really not seeing a strong trend one way or the other for April. Normally speaking, it's a fairly dry month, only about an inch of rain. So, at this point, I would say I'm not expecting a huge difference from normal in April, just because I don't see a strong signal one way or the other. But just bear in mind that because only 1 inch is normal, if we only get half an inch in April or we get an inch and a half, that's pretty much in the range of normal. So it would have to be, 2, 3, even 4 inches for it to be known as a really unusual month, or virtually no rain for it to be considered a really dry month. Oh, I see one. Do we have time for one more?
Yeah, go ahead.
There's one. I see one at the top there.
Any indication on spring temperature trends, early in the winter, late in the winter?
Are you thinking as of late February or more into April?
March, April, May.
Yeah, that period as well, just because we haven't seen a strong signal in terms of ocean conditions or anything, it's really hard to say what's going to happen during that time period. I am seeing right now, at least, this is a little bit earlier than you were hoping, but kind of early February is looking to be fairly warm. But then as we move into March, April, the years that I referenced as analogs, the 04 and 07, weren't, I don't believe, particularly unusual in the early spring. But just because I don't see a strong signal, I don't want to go one way or the other, because I just don't have enough confidence to say.
Are there any other questions for Scott? If not, please join me in thanking Scott for his presentation.